Hi, Math 2. So today we're going to review what you learned in class, which is solving an inequality. And so the first step when you're solving an inequality is to take what's inside the radical sign, the x plus 2, and set it greater than or equal to 0. Now, the reason that we do that is because we don't want to take the square root of a negative number. I know that you learned using the quadratic formula and when we were solving quadratics that you can pull out the I and have an imaginary solution. And that is true. However, when we are solving radical inequalities, we don't want our answer to be an imaginary number. We are only looking for real solutions. So if we subtract 2 from both sides here, then we get x has to be greater than or equal to negative 2. So this is one of our boundaries. This is our minimum boundary. And then we're going to do the same exact thing as solving a radical equation, but here we just have an inequality. So we want to get this radical sign all alone, which means we have to get rid of anything that's being added, subtracted, or multiplied to it. Here we're subtracting 5, so we're going to add 5 to both sides. Those will cancel out, and we'll have the square root of x plus 2 is greater than or equal to negative 4 plus 1 is, negative 4 plus 5 is a positive 1. Our next step is we're going to square both sides. The reason that we do that is a square and a square root are opposite operations. They will cancel out, and we'll have x plus 2 is greater than or equal to 1 squared, which is 1. And then we're just going to subtract 2 from both sides, and we get x has to be greater than or equal to negative 1. So when solving the equation, we get a different stipulation than when we just solved for the domain, when we just solved inside the radical. So when we solved inside the radical, we get that x had to be greater than negative 2. When we actually solve the equation, though, we get x has to be greater than negative 1. And so because we want to pick the one or the inequality that would make both situations true. So if I picked x is greater than negative 2, that won't make this one 2 because negative 2 is not greater than negative 1. So I'm going to pick x has to be greater than negative 1 because x being greater than negative 1 satisfies both situations. And so when you write this, you want to write it as an interval. X has to be greater than negative 1, which means negative 1 will be our lowest value, but x can be any number greater than negative 1. It can go infinitely greater than negative 1, so we're going to go from negative 1 to infinity. And this would be your answer.